Good morning, students. In the last period, we have discussed about the types of buffer solution and the buffer solution. In that, acidic and basic buffer solutions. Now today, we will see about the solubility equilibrium. Here, after we confine our attention to the primarily soluble compound, that is, the compounds, those dissolve only primarily in water. Such compounds, for example, we have taken that is the powder Rjcl. This Rjcl is put into the water and stirred vigorously. A small amount of Rjcl dissolves in water to form the saturated solution. Most of the salt remains undissolved. Thus, the solid Rjcl is in contact with the saturated solution. Rjcl is a strong electrolyte. Hence, the quantity of Rjcl that dissolves in water dissociates completely into its Ag plus and Cl minus ions and Cl minus. Here, a dynamic equilibrium exists between the undissolved solid Rjcl and the dissolved ions, that is Ag plus and Cl minus ions. This equilibrium called the solubility equilibrium, which is represented as this Rjcl gives the Ag plus ion plus Cl minus ions in the aqueous medium. This equilibrium is represented by this equation. The expression for the equilibrium constant is, that is, equilibrium constant A is equal to molar concentration of Ag plus into molar concentration of Cl minus to the molar concentration of AgCl. This is the, suppose this is the equation 1. Then this Ag plus and Cl minus ions. Well, the equilibrium constant K is equal to product of Ag plus Cl minus ions to the concentration of AgCl. The concentration of undissolved solid AgCl is constant. We may write that is the concentration of AgCl is constant is equal to K dash. By putting this value into this equation, we can get that the K is equal to molar concentration of Ag plus into molar concentration of Cl minus divided by, instead of AgCl, we can put the K dash. Then K into K dash is equal to concentration of Ag, molar concentration of Cl minus. And this, the K into K dash is the ionic product. K into K dash is the another constant that is called as the solubility product. That is the product of concentration of the ions in saturated solution, which is represented by the another constant, that is Ks Ksp is equal to molar concentration of product of molar concentration of Ag plus ions into molar concentration of Cl minus ions. This is the solubility product, that is K into K dash, is represented by the another symbol, that is the Ksp, where Ksp is the solubility product and Ksp is nothing but it is the product of concentration of the ions Ag plus and Cl minus ions. For the general solubility equilibrium, that is Bx Ay, the equation may be written like this way, that is Xb Y ions plus YAX. This equation can be into the equilibrium position or in aqueous medium in the ionic form for the general solid equation. Thus, the solubility product Ksp for this general salt equation, Ksp is equal to Ksp, that is the solubility product, is Xby plus into YAX. This is the solubility product Ksp for the general salt solution. General salt equation. The saturated solution, in the saturated solution of strongly soluble salt, the product of equilibrium concentration of the constituent ions raised to the power equal to their respective coefficients in the balance equilibrium expression at a given temperature is called as the solubility product. Means here we have taken the equation, that is the AgCl is strongly soluble in the water, but when the AgCl solution is taken into the beaker and it is beaker earthly solution, it will be soluble, and after the dissociation it forms the Ag plus and the Cl minus ions. Then the equilibrium constant K is equal to product of molar concentration of Ag plus ions into Cl minus divided by AgCl. Then, but the AgCl is the constant, hence it will be represented as the K dash. The K is equal to molar concentration of Ag plus into Cl minus divided by, instead of K dash AgCl, you can put the value that is the K dash. The K into K dash is equal to molar concentration of the ions, that is Ag plus and Cl minus ions. But this K into K dash is the solubility product, and the solubility product is given by and represented by the Ksp, where the Ksp is equal to ionic product, that is the concentration of Ag plus and Cl minus. On the basis of this, in the saturated solution of the primary soluble salt, the product of equilibrium concentration of the constituent ions raised to the power equal to their respective coefficients in the balanced equilibrium expression of at a given temperature is called as the solubility product. Then, what is the relation between the solubility product and the? Here we will discuss about the relation between the solubility product and the solubility. The solubility of a compound is the amount of grams that dissolves per unit volume. Solubility means the amount a compound, which is the solubility of a compound, is the amount in grams that dissolves per unit volume is called as the solubility. The molar solubility, the number of moles of a compound that dissolves in to give the 1 liter of the saturated solution is called its molar solubility. Molar solubility means what? It is the ratio to the solubility in gram per liter divided by molar mass in gram per liter. solubility. Molar solubility is equal to solubility in gram per liter. In gram per liter to the molar mass in gram per mole. In gram per, that is the molar solubility. Means the number of moles of the compound that dissolves to give the 1 liter of saturated solution. The number of moles of the compound that dissolve to give the 1 liter of saturated solution, that is called as the molar solubility. And this molar solubility is given by molar solubility is equal to solubility in gram per liter divided by molar mass in gram per mole. Suppose consider once again the solubility equilibrium for Bx and Ay. That is, the equation can be Bx Ay is given, that is Xb By plus Ya X minus. The solubility product is given by the equation, that is the KSP. Solubility product is the concentration of XBY plus into the product of YAX minus. That is the KSP. If S is the molar solubility, then at that time of the compound, the equilibrium concentration of the ions in the saturated solution will be, that is By plus ions is equal to, that is X and X minus is equal to the Y yes mole per liter, that is mole per liter, mole per. Then from these equations we can write the KSP is equal to KSP is equal to X yes into the Y yes, that is the concentration here. And for this equation may be coming from these values. KSP is equal, म्हणजे हे जे रिलेशन जे आहे हे रिलेशन आपल्याला सॉल्युबिलिटी आणि सॉल्युबिलिटी प्रॉडक्ट मधलं आपल्याला या ठिकाणी पाहायला मिळेल. आता दुसरी गोष्ट आहे, that is the conditions of precipitation. What are the conditions, or in which conditions the precipitation will be expressed? The conditions in the precipitation, that is the ionic product of electrolyte is defined as the same way as the solubility product. The only difference is that the ionic product expression contains the concentration of ion under any condition whereas the expression of KSP contains only the equilibrium concentration. म्हणजे solubility product condition काय आहे? That is it will be explained in the equilibrium conditions. And while in case of the concentration of the ions, it will be under any condition. If KSP, the solution is saturated and solubility equilibrium exists. IP, if ionic product is greater than the solubility product, the solution is supersaturated and hence precipitation of the compound will occur. If ionic product is smaller than the solubility product, the solution is unsaturated and precipitation will not occur. These are the conditions of the precipitation in case of the ionic product and the solubility product. Then we have to discuss about the final point, that is the common ion effect. Common ion effect. This common ion. आता कॉमन आयन इफेक्ट म्हणजे काय या ठिकाणी आपल्याला सहज आणि साध्या भाषेमध्ये आपल्याला समजेल. The common ion effect states that the ionization of weak electrolyte is suppressed in presence of strong electrolyte containing an ion common to weak electrolyte. And remember, the common ion effect states that the ionization of weak electrolyte is suppressed in presence of strong electrolyte containing an ion common to the weak electrolyte. म्हणजे या ठिकाणी आपण जर एखादा एक्झाम्पल जर घेतलं, for considering the weak acid, that is the CH3COOH. CH3COOH, it dissociates into the CH3COO and H plus ion, and its soluble ionic solvent, that is the CH3COON, CH3COO, it dissociates, that is the CH3COO plus Na plus. The CH3CONA, being a strong electrolyte, dissociates almost completely in the solution. CH3COO minus plus Na plus ions. Both the acid and the salt produces the CH3COO minus and CH3COO minus. This weak acetic acid dissociates into CH3COO minus, as well as its salt dissociates into CH3COO minus. Means both the acid as well as its salt dissociates into the CH3COO minus ions. And the CH3COONA dissociates completely, therefore it provides high concentration of the CH3COO minus ions. According to the Rjcl's principle, addition of CH3COO minus from the CH3COONA to the solution, the CH3COOH shifts the equilibrium of dissociation of CH3COOH to the left hand side, means it forms the CH3COOH ion. Therefore, the reverse reaction is forward, in which the CH3COO minus ion combines to the H plus ions and forms the CH3COOH. Hence, the dissociation of CH3COOH is suppressed due to the presence of CH3COONA containing the common ions. That is the common ion. म्हणजे common ion effect कसा आहे? weak acid, its dissociation is not completely dissociated. It forms the CH3COO minus plus H plus ions, while its salt CH3COO minus CH3COONA dissociates completely, it forms the CH3COO minus ions and Na plus. The concentration of CH3COO is higher in this case. When this is present into that solution, reaction will be reversed to form the CH3COOH. Means that reaction is suppressed due to the concentration of the CH3COOH. That is the common ions in both the acid as well as base. That is the common ion effect. We'll see the next chapter.